In this video, we're going to talk about something called the GL Utility Toolkit, or GLUT for short. We talked about it a little bit, but here we're going to get into some more detail and how it fits into the sample code you see. So first of all, the GL Utility Toolkit serves two major purposes. It interfaces with your operating system and the Windows system, which is part of the operating system. And to that end, there is a Linux version of GLUT, a Windows version of GLUT, and a Mac version of GLUT, all with the same function name. So you only have to write your program once. And GLUT has some application utilities, such as drawing 3D shapes for you. And this is one of the main reasons I like it. There are other ways of interfacing to the Windows system, but everybody has such a good time with the GLUT 3D shapes. So if you would rather use something like GLFW as the interface to the Windows system, you can, but you won't get the 3D shapes. Okay, so using GLUT to set up the window, this is in the init graphics function. As we talked about before, there is GLUT create window, which opens the window. And before that, you can set up some hints like I want to do color and I want to do double buffering and I want to do depth buffering, which we'll get to. And I would like it to start or one corner of the window to be in the upper left corner, and I would like its X and Y dimensions to be that. So yeah, that's what those are there for. And you'll see that in the init graphics function. Okay, also in the init graphics function, you will see the event-driven callback functions. So anytime the display needs to be redrawn, that's the function to call. Anytime somebody hits the keyboard, that's the function to call to go get the key. Anytime a mouse button goes up or down, call this function. Anytime the mouse moves, call this function. There's a whole bunch of functions there that we're not using, and you can just set their callback functions to null, or by default, they're set to null. And this idle function we will use, so we're just not using it right now. Okay, so here's what the keyboard callback looks like. It will tell you what the character was that somebody hit on the keyboard, and it will tell you where the mouse was when the key was hit. So if you're using the key to point to something or to select something you're pointing to, that's what you use it for. In our case, we're not using the X and Y. So we're just going to do a switch statement on the key. O changes to orthographic perspective or projection. P stands to changes to perspective. Q or escape changes to, well, exit the program. And a couple things that are polite. It's polite if you're going to look for a lowercase character, look for an uppercase version of the same character. And the reason is if somebody accidentally leaves their caps lock key down, if you don't look for the upper one, then they've got to figure out they left their caps lock key down, or they just get good and angry, wondering why they hammer on the O key and nothing happens. So it's polite to do both, upper and the lower case. It's also polite to do this. That is, if somebody hits something on the keyboard that's not one of the keys you're looking for, tell them that. Is I don't know what to do with this one. Okay, again, otherwise they just sit there and hammer on the keyboard and get angry. In the bottom of most of the callbacks, you'll see this function called post redisplay. Typically, you don't call the display function yourself. What this means is when the GLUT main loop with the event handler has nothing else to do, redraw the scene, which is usually right away. But there are some advantages in doing it this way as opposed to you calling the display function yourself. Here's the mouse button callback. Which button triggered that? Was it an up or a down? And where was the mouse pointing when that happened? In our case, we're tracking which buttons are down. So really what we're doing is we're just ORing in the button number, 1, 2, or 4, into active button, And then we will test that in mouse motion. Okay, so if you push down the left mouse button and move the mouse, you're asking to rotate. And so that's what's going on here. If the left button is down, read how much the mouse has moved and turn that into an angle. If the middle button is down, turn the mouse motion into a scale factor. And so that's why that is here. And again, there's a post redisplay down there to make sure that you redraw the scene so you can actually see the effect of changing the X rot, the Y rot, and the scale. All right, here's the animate function. This is, well, typically in our code, that's the name of the idle function. So if you set the idle function to null, then even though glut main loop has nothing better to do, it's not going to do anything else. It's just going to sit there and wait for more events. If you set the idle function to animate, then every time glut main loop has nothing better to do, it's going to call this function. And right now there's probably not a whole lot in that function, except this is one of the animation tricks we'll talk about. And the trick is you read the elapsed time, how many milliseconds since the program started, you mod it, you divide it, and that leaves you with this floating point global variable set between 0 and 1. And you can use that in animation. You can, for a rotate angle, you could say 360 times time, and that'll sit there and rotate. So anyway, this is how we'll use it, but we'll talk about this more, and you'll get to use this in project 2. All right, pop-up menus are easy to create with Glut. Is you add menu entries. Okay, you can add submenus, which are hierarchical menus. If you hit the right mouse button, right mouse button, that's what triggers the menu system. And so try it in the sample code. Hold down the right mouse button and you'll see these menus all pop up. This is really nice. It's easy to do and you can do it yourself. So you can add all kinds of things into the menu that just make your program more convenient for you. And there's 3D objects. Okay, these. There's a sphere, although our sphere function, if you look in the downloadable files part of the resources page, you'll see something called an OSU sphere. It actually is better than their sphere. You should use that one. But yeah, they've got a cube. Well, OSU cone and OSU torus are actually better than theirs too. But these they have that we don't. And they have a teapot, which is a computer graphics thing. I'll tell you about I'll tell you about the inside joke now. Um, Many years ago, there was a grad student doing research on rendering, and he needed a 3D object. And this was before you could scan 3D objects, before you could buy 3D objects. But he had a teapot in his office. He was British, Martin Newell. And so he painstakingly digitized his teapot, put little dots on it, measured X, Y, and Z with a ruler. Well, when people saw what he had, they asked for copies of it because, well, nobody else wanted to digitize their own objects either. And so the teapot became some kind of a standard test object in early computer graphics. Okay, when you're doing things like spheres and tori and cones, there are these arguments, slices, and stacks. Slices are the resolution going around it. If you have a hard time remembering what a slice must mean, think of a pizza. Slices go this way. And stacks go up and down. Okay, so that lets you set the resolution of the thing you're drawing. So, have fun with those. But until we discuss lighting, the 3D glut solids actually don't look that good. See, without lighting, if you just use color 3F, they look like blobs. Blob cube, blob cone, blob torus. When we learn about lighting, then you turn lighting on, and now you get, well, these nice things that vary intensity around the curved surface. And that's when they really become much more fun.